So if you think about it, this is pretty much at the heart of our course. This term, the title of the course is Advanced System Design. So we're really going to talk about systems design, but systems design is actually way more than what you will see in the next few minutes as I go through them very quickly. I'm not even going to be very exhaustive about this topic. The materials that have been uploaded in Canvas should be a good supplement to what I will talk about today. Nevertheless, the intention of today's lecture is just to simply give everybody a good grounding to start from, especially for those who haven't been exposed to these types of topics when they were doing their undergraduate program. Okay. Now, for those of you who've been doing computer science or information technology as an undergraduate program, this will probably be more of a review. But for the rest, this will probably be a new thing. So in order to balance out the starting points of everyone, uh, we'll just go ahead with the fundamentals, the very basic ones, okay, for everyone's appreciation. And for those who'd like to augment what we've talked about today, you can always refer to the references that have been posted in advance. So, okay, what do we mean by systems design? Well, it is defined, okay, as how the finished information system will operate. Okay, so if you look at systems analysis, which was our previous topic, systems analysis would have been uh, or would have tried to answer the question what. Okay, what is required, what is expected from the system. So it's more of a what, systems analysis. For systems design, it's more of the how. So how does it look like? How will this work? How will this operate if you have these certain conditions? So in order to differentiate analysis and design, a good shorthand would be the analysis part would be the what, the requirements, and the design would be the how. Okay. Now, your systems design, okay, is supposed to specify, okay, the best structure for the application and the best methods for the input, the output, and the user interaction involved in that system. So not only is it just a mere how or a mere way of doing things in order to achieve the what, it has to be the best possible how that you can think of. Okay. Uh, as the old saying goes, no, a very graphic one I would add. Okay, there are many ways to skin a cat. Okay, but we're not just simply interested in coming up with any way of approaching the problem, okay, or approaching the requirements. It has to be the best. Okay, and naturally, it wouldn't really make sense to do something that is suboptimal because at some point in time, okay, your organization, especially the users, will notice the suboptimality of your system, which would then lead them to perhaps make that request in the future to make it much better. Okay? So if you already know what's the best way of doing it, then you might as well do it. And sometimes, but of course, there's that caveat. Okay, sometimes doing the best uh, is not really limited or is not based on merely good intentions, right? Sometimes you really want to do things very well, and that's fine. But if you fall into the type of perfectionism, okay, that type wherein you know that you don't have the available skills, the capability, the resources to do what you think is the best, then it's more likely than not counterproductive on your part. Okay, so when we talk about the best, it is the best that you can reasonably or practically do at that particular moment. And that's fine. I mean, nobody's really going to fault you if you really can't do your best or the theoretical best. Okay. Um, but when we talk about the best structure, the best methods, ideally you'd probably be looking at best effort as well. Okay. And the design specification is based on the requirements collected at the analysis stage. So if you remember, the main output of systems analysis is requirements specification. So your design that comes after that, okay, would have to be would have to be based on the requirements collected. Now, what are the aims of system design? Now, why do we want to go through systems design? Now, why don't we just go ahead and hack? No, I mean, go do our code and do it or develop it. Or if you don't want to develop, you might as well go ahead, buy something off the shelf that appeals your eyes. No, okay. The only reason why, well, not really the only reason, but the reasons why we want to do an appropriate design is that, well, we want to make sure that the system that will come out of it would be easy to use. Well, naturally, it has to be convenient. It has to hit home right away with the users. If the very first thing that the users would see is that it's so difficult to use, I think we're missing out a big chunk of missing out a big chunk okay, of opportunity. Okay, uh, it's also important that the system can provide the correct functions for the end users. Okay. I mean, I think this is a no-brainer at this point. I mean, you're not going to create a system that is not really needed by the end users. Maybe it's nice, but at some point in time, the system will fall into abandonment, right? I mean, nobody's going to use the system anymore because it's not doing the functions that it was expected to do in the first place. Okay. You want a system that is rapid in retrieving data and moving between screen views of the data. Again, this is in relation to the convenience or ease of use. Uh, if it's not robust, if it keeps on lagging, diba? Then even if it does the correct functions for you, you can be frustrated with the outcome, right? And it's still not going to help. Okay. Definitely, you want a system that is reliable, that is secure, and well integrated with the other systems. So by coming up with a design beforehand, you can ensure that all of these things that we've just mentioned can be accomplished. Okay. Uh, Now, when we think about systems design, we always think of the ideal, right? If we have the opportunity to create a system, so this is what we have: 1, 2, 3, 4, 5. Well, unfortunately, when we come up with a design, we have constraints also to the design, and these constraints are not just self-imposed, right? I mean, these are constraints that have been there from the very beginning. Even during the analysis stage, you would have recognized these constraints. So more than constraints, they're like your givens. There's nothing you can do about it because it's already there. So what are examples of constraints? Okay, or the saying goes, no, the cards are dealt with. Well, hardware, that's a constraint. Okay, and when we talk about hardware or operating system, even it's not only based on the availability, okay, but it's also based on whether the users are familiar with the hardware or the operating system that they have to use. Okay, that's also a constraint. Um, Web browsers, I mean, especially for web-based applications, I mean, what web browsers are there? Naturally, this shouldn't be much of a problem, okay, but they tend to come up in situations. Okay, data links. Okay, so the interfaces between the application and the database. I mean, what's available? Are you going to work with an Oracle database or an SQL server? Okay, uh, and this is quite particular with enterprise type of applications. Okay, so you really need to look uh, at these data links as your constraints. okay, the design tools that's made available to you. Case is an example of a design tool. There are many other tools for design out there, so I'm not going to make any recommendation in this area. Methodologies and standards adopted by the organization. So if your organization, let's say, is a service management organization and it uses ITIL, then you can't use any other methodology, perhaps, okay, in that area. Or if the organization is pretty much used to agile methodologies, then it might be counterproductive to impose something perhaps in waterfall. I mean, just to illustrate the point. Okay. Other constraints would be industry standards. Okay, maybe there are rules or regulations by government that require certain formats. Okay, so those are constraints. System development tools or IDEs that's made available to you as well. I mean, these are things that would also sometimes they influence on the approach of the development. I've seen that in many cases. And the number of users to be supported concurrently and the performance required. Okay, so are you looking at a large organization with many people using the system, or are you looking at a very small, I mean, very niche market for your system? Okay, so those would be the things that would define your constraints. I mean, the constraints eventually will give you the boundary of your system. Okay, so and more often than not, these constraints would have come up during the analysis stage. So it's important that early on you are also aware of the limitations of what can be provided by the system. Otherwise, you'll if you're going to discover or unearth these constraints at a much later phase, you might, well, it's not impossible to finish, right? But it does put a dent on your ability to finish on time and within budget as well. Now, so in that sense, when you look at constraints, it's important that you have what is known as a design strategy. Okay, so a design strategy is a high-level statement about the approach to developing an information system. So these are because your strategy, naturally, you have a goal in mind, you have constraints at the same time. So what's your best path moving forward? So that's the whole idea of your design strategy. And it can include statements on the system's functionality, the hardware, system, software platform, and the method of acquisition, okay, if any, as well. Design strategy is similar to perhaps what you guys may have encountered also, like the concept of solution architecture. Okay, in solution architecture, you also consider the strategy very well. It also takes a look at the business side of things first before you go to the technical. But nevertheless, I mean, design strategy is like a catch-all. Okay, I mean, as long as you have an approach based on the goals that you want to accomplish and the constraints, the limitations that's concurrently present, okay, whatever plan you have to address these things, that forms part of your design strategy. Now, what are the elements of design? But there are some considerations when we start to think about the design elements that we look into. Okay, the first idea is: are we gonna look at a top-down or a bottom-up approach to design? Okay, so we'll talk about that in a while. Validation and verification. So how do we find out whether our design is okay? So how do we determine goodness of fit? Okay, so these two things will come up in the picture. Scalability. When you come up with a design, is it something that can work for a specific set of people, for a specific number of people? Or is it something that can move flexibly across a particular spectrum? Okay, so can it deal with more users? Can it deal with more diverse users? So those are things that you want to look into in scalability. And things like data modeling and process modeling. So last time we've talked about two types of diagrams, right? So the IFD and the DFD, and also the ERD. I mean, you've seen the difference between information flow and the process itself. So even in those two elements, okay, or two types, you can see that things like data modeling and process modeling comes into the picture of your design. Now, first consideration, top-down or bottom-up design. Okay. The top-down approach to design involves specifying the overall control architecture of the application before designing the individual modules. So, well, uh, as typically understood by the term top-down, so you have the whole picture first. Okay. This means that this is how your entire system would really look like. This is the general idea of your overall system. And then after you've defined the general overall frame, if you will, then you can come up with the specifics. It's only then that you start to pop in those individual parts within the bigger whole. Whereas the bottom-up approach to design starts with the design of the individual module first, okay? Maybe without prior regard to the other modules. So you do the individual modules first, okay? Establishing their inputs and outputs, and then builds an overall design from these modules. Okay, so and both approaches have their pros and cons, right? The advantage, for example, of a top-down approach, and you can surmise this, is that at least you're focused on the objective of the overall system. You're clear from the very beginning because you've really started from the overall intent, okay, the overall global intent, so to speak, and then you try to come up with your localized elements. Okay. Now, on the other hand, the difficulty with the top-down approach is that if your intended scope is really large from the very first place, it can be a bit overwhelming, okay, and perhaps in some cases discouraging, okay, to plow forward, because you will see that, okay, I mean, what's really expected of me is really a big thing, okay, and as you take a look at a big thing, you put in your project management hat, and then you realize, oh, this is something like it's gonna take me 100 years to finish. Okay, well, that can be a deterrent to success. Okay, so those are the pros and cons, among others, right? You can probably think of advantages and disadvantages for the top-down approach. For the bottom-up approach, the advantage is that, okay, it's very specific, it's very limited, it's something easy to do, and progress can be easily established because doing the individual modules can be quick. Okay, the scope of an individual module is greatly smaller, okay, compared to the whole system. So when you do the individual modules first, okay, then in terms of that sense of accomplishment, that feeling that you've been able to do something and make progress is highly possible. It's quite likely, okay, and you'll really see progress. Now, the challenge or the difficulty with the bottom-up approach is that you are expected to know what the overall objective looks like. But it is possible that you don't, or you might forget the overall objective. So as you keep on building your individual modules, it might seem like cancer, right? The cells just keep on multiplying, but it doesn't really have any regard to how far it should go. Okay, sometimes you'd be doing modules because they're easy to do. Okay, why don't we do this module anyway? It's easy to do, but that module may not be important. Okay? So the bottom-up approach would still need some sort of prodding from somewhere that, okay, I mean, to keep everyone within the same track. Okay, so nobody goes off course when they're doing the individual parts separately. Okay, Now for validation and verification, so there's a difference between the two. What's the difference? Okay, and sometimes people interchange it, but I think it's good that we know the official difference. The validation, this is the test of the design where we check that the design fulfills the requirement of the business users, which are defined in the requirement specification. So the design, you check whether the design actually ticks off everything from the requirement specification. So that's important. Okay, so that's you call that validation. Now, verification is the test of the design to ensure that the design chosen is the best available and it is error-free. So, validation is like an external activity wherein I take a look at my design, I compare it with what the requirements tell me. Verification is like more internal. Like, this is the design, is this the best that we can come up with? And is the design error-free? Or is the design suboptimal, or can we still improve on it? Okay. So that's the difference. I mean, you can do the analogy like validation is to external as verification is to internal. So if you really want to find out whether your design is really the best, it's verification. If you want to know whether your validation or if your system is really appropriate for the requirements given, you call that validation. So those are the two things, and you have to do both. As we said earlier, of course, it's important that we try to come up with the best design possible, with the best methods, with the best approach, with the best tools. Okay, of course, with best effort. Even if we aspire to have all the best technology there, but if it's not really appropriate to the stakeholders who will actually benefit from these systems, then it doesn't really make sense to go all out, right? Again, I'm also reminded of an analogy. You know, especially here in Metro Manila, you know that the roads in Metro Manila aren't really good. Okay, of course, to be fair, there are some roads that are okay, but in general in Metro Manila, they're not really that well paved. Okay, and in such cases, would you want to drive a supercar in Metro Manila? Okay. Well, basically, it's the better car compared to most of the cars that we have right now, the sedans, okay, or even the SUVs, in terms of performance. But naturally, based on your constraints, in this case, the roads that you have, then it is probably not the best or the most suited for your constraints. So again, I mean, when we try to come up with the best solution, the best technique, the best methods, sometimes we always have to keep the constraints at the back of our head. Okay, and even if we would like to be ambitious about what we can give us the best, okay, well, sometimes we have to step back, you know, and temper ourselves a little bit to see what is really more appropriate for the situation at hand. Okay, but I digress now. Okay, moving on, scalability. Okay, the potential of an information system or piece of software or hardware to move from supporting a small number of users to a large number of users without a marked decrease in reliability or performance. Okay, so that's the usual definition of scalability. So scalability, scale from a smaller number, you're able to work with larger numbers. Okay, and without noticing any difference in terms of performance. Okay. Now, if for example, if you start putting in more users into the system and everybody else would notice that the performance has been deteriorating, then your system is not scalable. It has a certain natural limit to how many users it can actually absorb. Okay? Uh, that's the counter example of what is not scalable in that sense, right? I mean, but if your system is scalable, okay, or at the very least, the design suggests that the system is scalable, then it's probably the best out there. The reason why you want to consider scalability is because you want to avoid having to go through this entire process again of acquisition, you know, initiation, systems analysis, and design, again, in the event of a larger number. Okay? And at this stage, it's probably good to say that the number of users should not be considered as a constraint to your design, right? Some developers would probably see it as a constraint, and they put that as a cap. But in other cases, putting a cap on the users is okay. It's a safe thing to do. It protects you from blowing up whatever it is that you have, right? And which is why in some commercial transactions, you probably would want to charge people for more money if they intend to have more users, right? So the pricing model on a per user license, I mean, that's the logic behind it. You want to ensure that those who'd like to buy or get access to your systems, I mean, you identify the number of users beforehand because you want to avoid a situation wherein you have a large number of users diving right in concurrently to your system and causing it to break. Okay, but regardless, I mean, you'd still want to have a system that is scalable. Okay, that can really consider large number of users. Okay, sometime in the future, even if it is not currently applicable at the present. Okay. Data modeling and process modeling. So let's go with process modeling first. Okay, this involves the design of the different modules of the system, each of which is a process with clearly defined inputs and outputs and a transformation process. So data flow diagrams are often used to define processes in the system. So we've seen that in the earlier topic. Okay. And you also have data modeling. So data modeling involves considering how to represent data objects within a system, both logically and physically. So in this case, the ERD, entity relationship diagram, is also used to model that data. Okay. And when you're coming up with a system design, it's important that you should have both. You should be able to do both conveniently. You should know how the process would look like. You should also know how the data would actually interact, okay, with the system. Now, that said, after taking a look at all of these considerations, so what are the major elements of a system design? Well, there are many, and there are many ways of defining it. One is the overall system design or the overall design. Okay. Another element, major element, is the detailed design of the modules and the user interface components. So you have the overall system, and then you have the individual parts, okay, in greater detail. You also have the database design. You also have your user interface design and security design. Okay. To preempt, okay, I won't consider database design in depth for this course because you do have another subject, which is advanced database systems. So you will, it's expected that you will learn much about database design in that course. But nevertheless, it's good for you to know that when you consider a system design, well, the database design is also important. Okay, so system design, or another term for that, is an outline design. I mean, from the term itself, you know that it's just simply a high-level view of your system. So high-level definition of the different components that make up the architecture of a system and how they interact. Okay, so system architecture, the design relationship between software, applications, hardware, process, and data for an information system. So that's system architecture. Okay. This is really also at the realm, or this is the realm of your architects sometimes. So if you've had an opportunity to deal with solution architects or enterprise architects, normally they have a huge amount of input in an outline design or a system design because of its high level nature, right? It's like a 10,000 foot view of everything. You just want to make sure that everything is working well at the outset. You're not really too concerned about the nitty-gritty details as long as they operate based on expectation. Then okay, that's all you need to know at this stage. Okay. Now, a detailed design, or another term for detailed design, is module design. Okay, it involves the specification of how an individual component of a system will function in terms of its data input and output, user interface, and security. All right, so it's really just like some sort of the opposite of your outline design. Module design is something more specific, more detailed, uh, and it focuses on a component of a system. So that's pretty much the idea behind it. Okay, the reference, the chapter that's uploaded in Canvas will provide you with more details, more tools in this area. So I'll leave that up to you for your own individual reading in that sense. Okay. User interface design, human-computer interaction. Okay, involves a study of methods for designing the input and output of information systems to ensure that they are user-friendly. Uh, Now, this is quite an interesting thing because even how your logos would be placed in the screen, or what happens if you swipe up, swipe down, left, right, okay, all these things, this is within the domain of UI. And typically, UI, and the more elaborate field for that is UX, or user experience, right? Um, and people who are experts in HCI, okay, take a look at these things. I'm not sure if you've had a chance already to. I forget now, because we also have a course in the MIT program that talks about HCI. So that's also a different subject. That's a different course altogether. So you can. I forget now if that has been offered. I remember it was offered. It's typically offered on the second quarter of the year, but uh, we're in quarter two, so I don't think we offered that yet. But anyway, let's take a look. Maybe we'll have that opportunity to be offered soon. Okay. Uh, but in any case, what we deal in UI design is really how the user will interact with the with the system, right? I mean, is it just going to be the keyboard? Is it just going to be a tablet with swipes and all that? Will it be based on voice? Okay, or will there be other passive tools like facial recognition or gestures? Okay, or if you're using augmented reality or virtual reality, that's also part of the user interface design. So okay, these are considerations, okay, that you would be thinking of when you're designing your system. Of course, in the more typical business sense, I mean, the traditional ones, your user interface would be pretty much your screen and then a certain input device like a keyboard. Okay, so that's pretty much it. Okay, at that basic, but it's not limited to that. Okay, input design. Okay, input design includes the design of user input through forms, okay, but also other methods of data entry such as import by file. So if we're just going to import files, or transfer from one system, or specialized data capture methods such as barcode scanning or optical or voice recognition techniques. Okay. There are many ways. I mean, at least designing your forms can be an important factor in your input design. Well, input design, it's a very, very specific design, specifically for input, but it is also considered part of your UI design as well. Okay. But UI design is specific to users. In this case, in input design, it's possible that the input will not come from a user. It can come from something else. It can come from an external trigger, right? In which case, there's no user interaction involved, but an input design still needs to be specified. Okay, so there's an overlap with UI, knowing that there are certain inputs that are not user driven. Okay, output design involves specifying of production of on-screen reports or paper-based reports. Okay, or it can be like output that will throw data to another system, to a database, to a file. Okay. Uh, Again, I mean, if it's for user consumption, then your UI design will come into the picture. Otherwise, if the user is not involved, okay, then there's really no UI or UX needed in that sense. So again, output design also overlaps with UI design, only at the level wherein the user is expected to participate. In other cases, if your expected output is just simply throwing a file to another system and that other system will automatically process it, then that's not part of UI design. Okay. Now, specific to interactions between systems, so if you have a system and you want that system to interact with other systems, then we go into that realm known as EAI, or Enterprise Application Integration. Okay, it's the process of designing software to facilitate communications between business applications, including data transfer and control. Okay. And this area or this domain is pretty complex because while there are no user interactions involved, uh, it can be pretty difficult because the formatting that's expected can be very unforgiving, right? And the thing here is that when you're dealing with other systems, you are faced with what you see is what you get. And for with respect to other systems, if you don't have control of those other systems, then there's nothing much you can do, right? You might have an opinion that the other system is suboptimal, but it's not that sometimes that's not your concern anymore, especially if those systems are not owned by you, right? So you just make do with what you have. For example, this can be very important when you're dealing with financial transactions with banks. And while in the last decade we've seen very serious modernization efforts of banks, okay, a lot of them still rely on legacy systems to function properly. Uh, well, the legacy system still exists partly because of regulation. Okay, the law, uh, in a way, forces them to still maintain these systems for record purposes. But in any case, the idea there is that you're dealing with different types of technologies across different generations. So it's when you're designing interfaces between systems, okay, you have to be aware of what the other side looks like or what the other side can handle. And sometimes you'll be forced to be creative around it, right? So right, it's a good challenge to have in some cases. Now, for interfaces that are pretty much well established, meaning there are perhaps standards that has been agreed upon worldwide, okay, it's possible to develop software known as middleware. Okay, so that would facilitate the communication between the business applications, including data transfer and control. I mean, there are a lot of big companies that specialize in middleware. I know Oracle does that primarily because they have access to their own databases, right? I mean, but even if it's not an Oracle database, they do have middleware that can interface with different types of databases. Okay, so that is an improvement. So instead of coming up with your own middleware, which you develop from ground up, you can just simply buy something off the shelf. So you do have off-the-shelf middleware products. Okay, and that's a good advantage. But in the old days, I mean, when you design middleware, when you develop middleware, it's really pretty much a bespoke development. Okay. Well, the last design that we've talked about earlier is the security design. So when you look at security design, there are 4 attributes to look into. You look at authentication. Okay. You want to make sure that the one who sent the data is actually the same person you expect to send that data. So it's not a fraud. Okay. It's not an impostor who sent that information. Authorization refers to someone who has the appropriate access to that same set of data or he has access to that system. Privacy refers to that idea wherein one user is unable to have access to what the other user might have. Okay? Especially if that particular user doesn't have the authorization to take a look at what the other user might be using. So there is that sense of compartmentalization. Data integrity, okay, this is also part of security, wherein there's no data corruption, that whatever happens along the way, what was expected to be complete will still be complete throughout the process. So data integrity is also part of security. Sometimes when you think of security, we're thinking of intruders. But as simple as data corruption, that is also a security concern. Okay? And sometimes corruption happens not because of malice. Okay, sometimes because of uh, some crosswire. I mean, like one system was doing something and another system was doing something else, and they were perhaps accessing the same data at the same time. Okay, they made changes to that same data. Okay, there was no synchronization involved. Okay, that's also security. I mean, there's no malice involved. Okay, but that still falls in the realm of security. Okay, and with that, that pretty much covers the overview of systems design. As I said earlier, you can take a look at the chapter that I've uploaded. That chapter also provides in detail database design, but I won't cover database design in this course because you do have another course that will deal specifically with database management. So that will be omitted conveniently for our purposes. Nevertheless, there are other things included in the chapter that would still be useful for you. So I do hope you spend the time to look at it as well. Okay. Are there any questions on this topic? Okay. Okay. If there are no questions on this topic, I'll stop recording.